doing this right now. I'm going to say experiment.
You want to move forward?
Calibrate. Yeah, that'll work.
I'm not sure what's going on.
All right.
Look at this. I don't think I can. It's not Snapchat.
All right. Cool.
Mr. McKnight?
Yes.
Is it okay if we move the Dawn soap over a little bit? Oh,
Yes.
thank you.
And y'all can get, as long as you stay like this distance away, you can get on different sides to see what's going on. All right. Take a look at what we're doing. I am measuring the pH of this stuff. And I'm getting a pH of this acid of about 1.18. Could you figure out the concentration from that?
Theoretically, you could.
Do it.
With a calculator, you could.
Go get a calculator. Figure out what's the concentration.
Go stop. Where's mine?
I can't because it's a...
Somebody get a calculator. This is a strong acid. It has a pH of 1.18. What is the concentration of this acid?
You mean double tap on? It doesn't work like that. That's taking a picture.
Concentration is 1.7.
I can't flip it. Unless you want me to turn it around.
1.72 or 0.172?
I'm not sure. I was messing with Jackson.
Okay.
What did you say the pH was?
pH is 1.18.
I have 0.066.
Wait, what is the concentration?
I got 15. Wait, what?
But I also maybe...
That's not
10
right.
to the negative 1.18 equals.
Yeah, that's
that should be right.
0.066.
0.066.
Yes. Is the
Okay,
answer.
so I'm saying that there should be about 0.066 molar HCl based on the pH. pH is not super accurate, folks. It just isn't, okay? This is measuring it to 3 sig figs. I would not trust it, but I would use it to kind of figure out where I was. What I'm going to do instead is I'm going to add a base to this. How will I know when the moles of acid equal the moles of base?
When pH is 7.
The problem is, isn't my pH going to be real level and barely move and barely move and barely move and barely move, and then it's going to go boom?
Be really
right?
careful.
Be really careful. Yeah, but it's still relying on me to stop, because if I don't stop in time, the computer doesn't help me. I've gone past.
Which is why you add an indicator.
I'm going to add an acid-base indicator. What does an acid-base indicator do?
Turn funny colors.
It changes color. This is phenolphthalein. Nope. My bad. I'm glad I looked. This is thymolphthalein. That's not what I wanted. I want phenolphthalein.
Wait, what was
Thymolphthalein gonna do?
Class of AP Chem killed.
I don't know what color it changes at.
High school AP class killed and firing.
All right. This is phenolphthalein.
Teachers are...
Phenolphthalein is wonderful, wonderful stuff. 4 drops. Anytime you're using phenolphthalein, you need to make sure you wash your hands thoroughly afterward. Why?
Because it's poison. Oh no, it's a diuretic.
Oh, it's beyond a it's not a diuretic. It's something even more fun.
A laxative?
It's an extremely powerful laxative. So, if you get that on your hands and then you go to grab a snack during the break, and then you go to, what's your next class?
Statistics?
Statistics. So you're sitting there halfway through statistics and all of a sudden your life gets interesting. Okay? Wash your hands with this stuff. Now, this indicator is clear, colorless in an acid. Dun, dun, dun. It turns pink in a base. It changes color at a pH of 8. Is that what I want for the equivalence point?
No.
What do I want? But think about how your little graph goes. It's going to be hanging about 1, 1.5, 1.5, 1.5, 1.5, 1.5, 1.5. Boom! Right. When it goes boom, it's going to go right past 6, 7, 8 altogether. That part of your graph is basically vertical. So that's what we call in chemistry close enough. I want something that is going to change color within a point or two pH-wise of what the equivalence point should be. And it is so vertical at that point, it's not going to make any difference. So, I'm going to lower this so that I don't have stuff spilling everywhere. I'm going to start this, and I want to make some comments as we go. So, I've started off, it's at 0. I want to get this to just like a fast drip, 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 drip kind of thing. So,
Kind of migrating.
still measuring pH here. So what's happening to my pH?
It is slowly inching upwards.
It's not moving very much, okay? I'm adding some of this base. I'm at 1.2. Is this unexpected or expected? I'm going to crank this up a little bit faster. There we go. Okay, I'm starting to see a little bit of an increase.
Will it turn pink really quickly? Like once it like.
What's going to happen now, think about what's happening here, is I have a drop of base falling into the acid, right? So where that drop hits, what's right there at that spot when the drop hits it?
Or
Water.
the base.
At the base, because that's the drop that's falling, right? And the acid is all around it. Now, as this thing stirs, what's happening to that drop of base?
Getting mixed in.
It's getting spread out. So aren't you having like a really concentrated base that's falling and then spreading out? Here's the trick with this. What you are looking for is a flash of pink, because where that drop hits, you're going to get a little flash of pink color from the base, and then if I stop the drops, it'll go back to clear because there's still more acid. As I start seeing that little flash, I'm not sure whether the light is helping me or not. Somebody have like a piece of paper. I'll just use this. That's better, right? Now we can actually see this. I think I have way too much acid in here.
You're gonna need more.
I think I am, which is not what I wanted to do. And now I'm going, what was I thinking? That's way too much acid. I'll tell you what we're going to do.
Go on the base?
No, we're just going to pour some of this out.
Can you tell me what's going on here?
Okay.
You are an awesome videographer.
That will probably be a little bit better.
I'll say in the description, skip to 10 minutes.
Okay.
Oh my god.
Do not do what I am doing right now.
Is this hey, you hold my beer pump?
Oh, we can just continue this and just cut it.
This is called I've been doing this a long time. You would remove it and hold it over a sink and use a funnel. All right, now let's see if we get something slightly better.
I don't even see it.
When doing a titration, what you are looking for is a pink color that begins to kind of appear and then fade away. I don't like those bubbles right there.
Oh, I'm serious.
I see it.
Okay, I'm going to let this fade away.
Move it, gang.
If you are not seeing, okay, do you see the little, let me get a drop. Do you see a little bit of a pink color where the drops are hitting?
Yeah.
So you get a pink, and then when I stop, it fades away because there's still more acid than there is base. When you are doing a titration properly, when you see that happen, that is the system's way of saying you're starting to get close to where this is going to take off. Slow it down. So you can have it kind of go in a fast drip, 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 but when you start seeing that color, slow it down. Now, as we go, I'm going to let it just drip like that. Notice it's lasting longer with every drop. Okay? What is this telling me?
Your pH is getting closer to 7.
I'm getting pretty close to a change to go from acidic to above 8. And that means slow it way down. The end point of a titration, we're up at pH of 5.6 right now. Collect. Append. So I had it turned off, it stopped graphing, is why it's not showing the graph, but we're starting to come up right now. The end point of the titration is the first drop where it turns pink and stays pink. Okay? So I add that and I go, it's pink, and if it goes 20-30 seconds and it doesn't fade, I go, that is my equivalence point. And according to this, that's not bad, because that's like 7.63. That's right about where it ought to change. So, if I measure the volume times the concentration of the base equals the volume times the concentration of the acid, right? Because at a pH of 7, the moles of acid equal the moles of base. Does that kind of sort of make sense? As long as you know the concentration of one of them, you can figure out the concentration of the other. And that's all a titration is. It's using a known thing to measure an unknown thing. Now, what happens if you go too far? You see that nice pale pink color? Notice that color is different.
Pretty dark.
When you get to that, you went too far. What can you do?
Dump and start over.
Dump it all and start all over again. Normally, students get kind of paranoid about that. They don't want to have to start over. Letting this thing go, what do you see it doing, basically?
It keeps skipping.
It's going to keep skipping, but it's going to start to level off right here because I've used up all my acid. Now I'm just adding more base, and the concentration of the base is going up, and it's going to start to level off at that point. Okay? Students normally get a little paranoid. They don't want to have to start over. I don't want you to have to start over, so people get kind of nuts. The biggest kind of nuts sometimes is I've had students standing there going, okay, that's it, we're done. And I'm looking at it going, it's as clear as that. No, you're not done. You know, not that, that's too far, but this isn't done at all. You're not there yet. You want that one drop where it turns light pink and then it stops. Okay, now, time out. Real world time. True or false? I could put the acid in the beaker and the base in the burette and do a titration.
Assuming that the base was your unknown, yes.
Could I
No.
put the base in the beaker and the acid in the burette and do the titration?
No.
Yes. I could put either one either place. Now I've got to be really careful about measuring my volumes, okay, but as long as I measure my volumes correctly, all I need is acid in one and base in the other, right? Why would I want to start with acid in the beaker?
Because it's a lower pH.
Starts at the bottom, goes to the top.
You can use phenolphthalein.
If I start with acid in the beaker, what color was it?
Clear.
In a clear background, can you see a pink flash warning you to slow down?
Yes.
If it would have all been base to start with, what color would it have been?
Pink.
Would you have been able to see a clear spot in the middle of all that pink, or would the pink just have made it all look pink?
Probably would just be most.
So you wouldn't get a warning, okay? You want to pick something where you're starting with either the lighter color or the colorless one, and it's going to go to the darker color or a color like pink in this case. You want to be able to see. We call the point where you add that last drop and you go, okay, that's it. That's where my moles of acid equal moles of base. It just turned pink, light pink, stayed there. I'm done. Write it down. That is called the end point. Okay. What's the equivalence point?
Seven pH is 7.
Moles of acid equal moles of base. What's the end point?
Acid's all gone. Base.
Your indicator changed color. Are those necessarily exactly the same point? But if you design the experiment properly, they ought to be really, really close. And this is your only warning, so you are titrating to the end point and assuming that that's the equivalence point, okay? If I were doing a titration of a strong acid and a strong base, what do I know the pH is at the equivalence point?
7.
So I want something that's going to change color around 6, 7, or 8, because that's on the vertical part of my graph. Would I use a acid-base indicator that changes color at a pH of 2? No, because when it changes color, I'm nowhere near the equivalence point. And I wouldn't pick one that changes at 11 either, okay? Hold on, I got one thing to give you because